Okay, welcome America, welcome Justin Bieber. Today we'll be doing other properties of angles in circles. So before we start, I thought I would kind of just explain this concept first. Let me get this going here for Liam. Okay, so if we take a look at, we know a straight line, the measure of a straight line in degrees is 180 degrees, okay? If I show you half of that is 90, right? And I put a circle right here. We can see that the relationship between the measure of this 90-degree angle inside this circle, here the relationship that's connected, or the relationship is half of the circle to this 90 degrees. An entire circle is 360 degrees. Half the circle is 180. So the relationship between the measure of this angle and the arc is times 2. So that's how we remember it. And a lot of times we get confused about which direction we're going. Sometimes they give us this arc, they ask us for this angle, we have to cut it in half. Sometimes they give us this angle and they ask for the arc, and we have to multiply it by 2. So it depends on which way we're going. I think this is the easiest way to remember this concept. So we'll get a problem that looks like this, and we're asked to find the measure of this angle. Well, if we know, we can find a measure of the arc on the other side, which is right here. We know the measure of this angle is half of that arc. So how can we find the measure of this arc? We know that the circle is a total of 360 degrees, and we are given the measure of this arc over here is 120. So the measure of this blue arc is 360 minus 120. Are we good with that? Okay, so that's 360 minus 120. And that's 240 degrees. And you guys check my work because I don't have a calculator out. So if the measure of this arc is 240 degrees, and the relationship between this arc and this angle is half, the measure of this angle is 120. How are we doing? I got one thumbs up. I'll take it. All right, we are moving on to slide 46. This is the next type of problem today. We have two chords and they're intersected, and they are intersecting not at the center of the circle. And we're given the lengths of these segments. And we're asked to find the missing one. So what we can do is we have to memorize these formulas. No one's ever gonna give them to us on a formula sheet. We just have to know when we have two chords that intersect, and we're trying to find the length of a segment, we can multiply 2 times x, and that should equal 3 times 6. So we'll write it out over here. 2 times x equals 3 times 6. Divide both sides by 2, and we get x equals 9. That's it. It doesn't get any harder than that. What does get more difficult is remembering when you get a problem that looks like this to multiply the length of the two segments together and set them equal to each other. Questions? Trying to go quickly because I know I have a lot of slides to get through, and I want to do each of these types of problems. So if you need to review for a retake or for your test, you'll have me doing each one of these types of problems, and you'll know you can fast forward to the one you want to look at. Okay, so now we've got two chords again that are intersecting in a circle, not the center, right? In this diagram, they call this circle O because the name of the circle is the center, and it's always a capital letter. Chords A, B, and CD intersect at E. Okay. If the measure of arc AC is 72 degrees and the measure of angle AEC is 58 degrees, how many degrees are in the measure of arc DB? Okay, so as we learned in the video last night, we need to average. The average of these two arcs is the measure of this angle. When we average two numbers, we add them up and we divide by 2 when there's two numbers. So for example, the numbers 5 and 3, if we need to average 5 and 3, we know the average of 5 and 3 is 4. We would add 5 plus 3 and we get 8, and then we divide by 2 and we get 4. So the average of 5 and 3 is 4. So we're averaging 72 and x, and we should get 58. How do we write that as an equation? When I average x, oh, there's nowhere to write this. Oh, good job, Cheryl. When I average x and 72, average them, I should get 58. There's our equation. We learned how to write equations from diagrams at the beginning of the year. It was very difficult. It gets easier as the year goes on. So is everybody okay with how I wrote this equation? Okay, now I'm just gonna multiply both sides by 2 and subtract 72. If anyone has that done, that'd be awesome. So what is that? Is that 116? Subtract 72, what do you get? No, not dividing, subtracting. Take a calculator out, guys. It'll be faster for me as well because I'm recording. Did you guys get 44? The phone should be away, unless you're using it as a calculator, which you don't really need because we have Desmos. Did you get 44? Okay, so excellent. All right, thank you. So the measure of arc DB is 44 degrees. Notice they're not the same. The measure of this interior angle, however, is also 58 because these are vertical angles. And if you need the measure of these angles, all of them together are 360, and 58 plus whatever this angle is 180. These are all concepts that we've learned before. The measure of this arc would be the same as the measure of this angle if this point was at the center of the circle. That would make it a central angle, but it's not a central angle. The next slide I'm moving on to is slide 50. Okay, this is the next type of problem. So here we have a secant line. It cuts through the circle twice, 1, 2, and then we have a tangent line. Sometimes these problems will be 2 secant lines, some they'll be 2 tangent lines, and then some of them look like this, 1 secant line and 1 tangent line. They're all the same formula. It's the large intercepted arc, the big one on the outside, minus, that was a weird sound, the small intercepted arc, subtracting them, divided by 2 gives you the measure of this angle. Again, a formula you have to memorize. We know we're given the big intercepted arc, but we are not given the small one. We have to find it first before we can do the problem. So how are we going to find the measure of this arc here? We know the entire circle is 360 degrees. And we know this arc is 152, and we know this arc is 152. So this arc that we need is 360 minus 152 minus 152. Somebody do that on the calculator. I'm going to write it out here so we know later on what we did. And what's 360 minus 152 minus 152? Thank you, 56 degrees. I'm going to write it on our diagram. Now we have all the information we need for the formula. We can do 152 minus 56, cut it in half. Somebody's doing this. And what do you get? Somebody? $50. I got 50 as well. Anybody else get 50?
Isn't it supposed to be 152?
Oh. Yes. 152 minus 56. There we go, 48. Let's erase that. Thank you. Last thing I need is a mistake in my video. 152. Oh my gosh, I can't even write today. There we go. Okay, 48 degrees. Any questions on that? Okay, like I said, each type of these problems in and of itself is not difficult. What you're gonna get is you're gonna get a diagram that looks like this, and you're gonna have to remember, what do I need to do again? Oh, I have to take the large intercepted arc and subtract the smaller one, cut it in half, and then that's the measure of the angle. 52. 2 more types of problems, and they're both the same type of problem. This one is given to you as 2 secant lines because these lines cut through the circle, right? Hits it once, hits it twice. this relationship, and this was the last type of problem I did in the video last night, is the hardest one. Not the hardest, but it's the one that most people forget. And it is the exterior segment length times the entire length equals the other exterior length times the entire length. So how do we write that out? 6 times the entire length is 6 plus x. Equals, on the other side, 5 times the entire length, 5 plus 7, 12. Now, the most common mistake for this type of problem is to multiply the 6 times the x and the 5 times the 7. If you do that, if it's a multiple choice problem, I can guarantee you that your answer that you get, which is wrong, will be one of the options. Okay, so just keep that in mind. So now we need to distribute the 6. 6 times 6, and then 6 times x. 36 equals, or sorry, not equals. 36 plus 6x equals 60. Subtract 36 from both sides. What is that, 28? 24. Six times 4 is 24. I'm getting the value of x is 4. Somebody correct me if it's wrong before I move on. Anyone else get 4? Perfect. All right, we're going to do one more example. This type of problem looks different, but it's the same as the one we just did. We've got one secant line. It cuts through the circle 1, 2 times, and then we have a tangent line, so it just hits the circle once. It's the same formula. It's the exterior part of the segment times the entire length, so 4 times 16 equals, now on the other side, the exterior part of the segment is x times the entire length also happens to be x. So it's just x times x, that's x squared. 16 times 4 is 64. And now we take the square root of both sides to solve this equation. And we get x is 8. Questions? I think that was the last one I wanted to do. Yes. Okay, I've done one of each type of problem, and now we're going to finish what we need to do in class. Any questions before I hang up? Going once, going twice. All right, thanks for watching.